Okay, the recording has been started. I hope you're able to see my screen as well, right? Can you confirm this also? Are you able to see my screen? Is my screen is visible? Okay, then we are good to go. So let us do a quick recap about the yesterday session. So what we were discussing in the yesterday session, if you remember, we were talking about the preprocessor. Yes or no? Preprocessor is not there in Java. I mean, it is not required in Java, but it is required in C and C++ programming language. So to keep it very simple, preprocessor is a kind of tool where it is going to include the statements, header files for the C programming language. The header files we have discussed yesterday, right? Include standard input.h, include math.h. So these things will be taken care by the preprocessor, especially for C and C++ programming language. However, when you come to Java, Java does not require preprocessor because Java uses the classes and interface in the packages, right? So in order to load these classes and interface, the loading will happen in the runtime, not in the compilation time, right? So that is the reason why by design, it is designed in such a way that the preprocessor concept is never taken care in the Java programming language. Whereas in C and C++, the loading of header files will be taken care during the compilation time. Whereas in Java, it is going to be taken care in the runtime. So, and the preprocessor concept was eliminated in Java. So you can revise that video once again if you have any doubts. So we have understood two differences, guys. What is the first difference? First difference is why C and C++ are static programming languages and why Java is dynamic. So we have answers for that, right? Second difference is why preprocessor is required in C and C++, why not in Java. So that also we have understood in the yesterday session. And today the third the major difference and the very important difference for the interview room. Every time, everywhere, even though if you are a 5 years experience candidate or 10 years experience candidate, even though if you are a fresher, whomever you can be, right? Whatever your resume says, this question is very important. What is the question? Why C and C++ are platform dependent programming language, and why Java is platform independent programming language? Very popular interview question for the interview room. So let's get it started. Sometimes, even though you keep the Java in your resume, the question can be in the opposite way. When I say opposite way, they would ask you why C and C++ are platform dependent. Instead of asking the Java question, they ask you the opposite question. They ask you why C and C++ are platform dependent. With respect to this, they would ask you the follow-up question, which is why Java is a platform independent programming language. So this is a very basic understanding. In order to understand this, I want you to uh, put some attention here. So theoretically, I can say that for this particular question, let us take let us draft the question like why C and C++ are platform dependent programming languages. Okay, I'm taking a sub question. Okay, the answer could be very simple. Theoretically, it will make some sense. So what does the theory says? If any programming language I'm just confirming if my screen is okay. Any programming language allows its application. Any programming language allows its application to perform compilation and the execution on the same operating system. Then that programming language is called as platform dependent programming language. Dependent programming language. So this is what the theory says. By looking at this theory, we might need to understand something internally. So why this is the theory is drafted like this, isn't it? So examples for this are, I can say that C and C++. So theoretically it is okay. Theoretically it is making some sense and it is very easy. Practically we will understand why C and C++ are platform dependent programming language. To understand this, I want you to concentrate on this paintbrush. Let me open my paint screen. So let us understand that. Let us say that I have a computer, I have a machine, guys. I have a computer machine. So this is my computer machine, right? So let me quickly say that this is my computer machine. So this is my machine and it is running on Windows operating system. So which operating system I'm using? Windows operating system. Okay. So in my computer machine, I am opening a notepad. What I'm doing? I'm opening a notepad. So let us say that this is a notepad. So I am writing a C program. Okay. I want to keep a simple pseudo code, simple plain code. My code says, let us say that integer a equal to 10 and integer t equal to 20, and these are the two inputs, and again my code also says that there is another integer which is calculating the above two integers a plus b. A very plain code, it is not even the C language, a pseudo code. Just for the understanding purpose, I am writing something in the notepad by opening my system. My system is working upon which operating system? Windows operating system. In my Windows operating system, I have opened a notepad. In the notepad, I have written 3 lines of code. Let us assume that these lines of code are part of C programming language. Right? So this is an assumption. So this is the text, this is the notepad and I have written some 3 lines of code, and let us assume that this is the part of C programming language. Whatever code that you write, okay, whether it can be a C language code or it can be a Java code or it can be the C++ code, when you write a code, that code you call it as what? The source code. Always remember, you call that code as what? The source code, right? So as soon as you complete writing the code, you need to save that code. So since you are using the C programming language, you have to save that code with an extension called .c extension. You can keep any name. I want to take the name as test.c. Okay, the test is the file name. Okay, test is what? This test is the name of the file. You can keep any name, file name, and .c is what? The extension. So when I say test.c, it means that this particular code is of what? C program language type. Test.c means .c is what? Extension. So I have opened my computer. My computer is working on Windows operating system. I have written a piece of code, and this is the C language code. Just an assumption. And you call this as what? You call this as a source code. After writing your source code, you need to save that source code in such a way that it is following .c extension. You can give any name. In my case, I am giving test.c. Right? So coding has been completed. After completing my coding, what I want to do, I want to perform an action. What kind of action I want to perform? I want to perform the compilation. So why I am performing the compilation? Compilation is going to check each and every line of code whether it is following the C language procedure or not. The job of the compiler is to identify for errors. If there are any errors, the compiler will say, hey programmer, you have made some errors, please correct those errors. If there are no errors, then compiler will happy to compile this code successfully. So what is the job of the compilation? The compiler, when the compiler is coming into the picture, okay, the compiler will check each and every line of code one by one. First line, second line, and third line. After scrutinizing all the lines, it is going to perform the compilation. So when the 100% compilation will happen, when there are no errors in your code, the 100% compilation will happen. So after the successful compilation, it is going to generate another file. It's going to generate what? It is going to generate another file. That name of the file is what? .exe file. What is that? .exe file. So the name of the file is test.c, right? So it becomes test.exe. Exe means executable file. So the high level language is going to get converted to what? The machine understandable language, something like one zeros, something like that. You don't understand this, but your operating system can understand this, right? So the source code is in the form of which language? Is in the form of high level language. High level language. When I say high level, what does it mean? High level, you can understand this. Can you read this? Yes, I can read this. You can also read this, right? So after the compilation, the what compiler is going to do? Compiler is going to do a lot of things in between. It is going to check for errors. It is going to check if the program is returning as per the C programming language standards. Okay, if it is finding the code as error free, the code is out of any errors, then it is going to do what? It is going to perform the compilation. After the compilation, it is going to generate the .exe file, which is what? The machine understandable language. For okay, then the machine and .exe file will be, I mean, code will be generated. This code is something like zeros and ones. So I am sequentially taken like 10101. It's not like that. It could be a sequence of zeros and ones. You cannot even expect the expect the order also. You cannot even guess the order. Only these things will be understood by the your system, your computer, right? So after this, what happens? So this is called as what? This is called as executable code. After the executable code, what happens? It will go through the execution. The process called as what? Execution. What execution actually does? Execution will execute all the instructions that was generated by the compiler. Then it is going to produce the result as expected. So what is expected result? You want to give two inputs like 10 and 20, and output should be the summation of two inputs. Output should be what? Output should be 30. So you will get the output in in your Windows operating system, which is what? 30. So this execution will be taken care by which engine? There is an engine called C engine. Since you are using the C programming language, there is an engine called C engine. This C engine will help the machine code to get executed successfully to generate the relevant output. So what are the things that are happening here? If you observe here, you are using the Windows operating machine. First thing, first observation. Okay? Your system is working upon Windows operating system. First observation. Okay, second thing, what you are doing in your machine, you are writing a piece of code in your notepad, right? And after writing this, you are saving it with the .c extension, test.c. Name of the file is test.c, right? After this, what you are doing, the third step is you are performing the compilation. The compilation will convert this high level language to which language? Low level code. Low level code is nothing but the machine understandable language, right? So what fourth step is involved? Fourth step is actually as the machine code, low level code. Okay, fourth step is actually having the machine code. So after converting all these things to the machine code, there is an engine called C engine. This C engine will actually performs execution so that all this machine level language will be converted to get the relevant output, which is what? 30, right? But here the idea here is, see the if you see this execution, forget about this execution. Now let us come back to this bytecode. Let us focus on this, especially on this bytecode. Fourth point, focus on this fourth point. Very important, this fourth point. Okay? Very important. Now you see, so we have test.exe file, test.exe, right, which contains executable code. However, it is generated as per the Windows machine specification. Okay, what are we understanding with this statement? So we have on the, especially on the fourth point, something got generated, some machine code has been generated. So this code is called as what? .exe code, text.exe code. This is also called as what? Executable file or executable code. But this code has been generated as per your machine specification. Which machine you are using, guys? So which machine you are using? We are using Windows machine. As per your Windows machine, this code is getting generated. Are able to follow? In future, if you are not, instead of using Windows machine, let us say that in future I am using a different machine, right? I don't want to use Windows machine. I am using a machine like Mac machine or Linux machine. Okay, instead of Windows, I am going for a different machine. Okay, I am going for what? I am going for a different machine. I'm going for Mac or Linux operating system. Okay, when I use Linux operating system, if I go through all the stages, so stage 1, stage 2, stage 3, stage 4, okay, in the exactly the stage 4, I will get a executable file in the form of ones and zeros. This executable file is what? It is generated as per the Linux machine specification. Okay, this executable file, this .exe file gets generated as per the Linux machine specifications. Okay, whatever the machine that you are using, for example, in future I am using it other different machine, like I am using a MacBook. Okay, I am following the same steps 1 2 3 4. Exactly at the fourth step, I am going to get the .exe file is going to get generated. Obviously, .exe file is going to generated according to the MacBook specification, Mac machine specification, not Linux. Mac machine specification. When I use MacBook, I get the .exe file as per the Mac machine specification. So the idea is very simple. If you are using Windows machine, you get the executable code in the form of Windows specification. If you use Linux specification. If you use Mac specification. Then where does the picture comes? The C and C++ is a platform dependent. Here the actual question is coming. Why the C and C++ is platform dependent? Let us say that I am able to generate successfully the machine code or the executable code. This is my executable code. Yes or no? This is my executable code. Okay, this code has been generated as per my Windows specification. Okay, as per my Windows machine specification. Right? What is the name of this code? Test.exe. Right? In future, if I wrap this code in the form of email, if I am wrapping this code, if I am downloading, if I am what we call it as if I am attaching this file, or if I am attaching this file in the email and I am sending it to the different machine. Okay, I am using an email. So I am using an email and I am sending this code, attaching this code in my email, and I want to send it to a different machine. Let us say that the different machine is something like the Linux machine. Okay. Linux machine. Okay, Linux machine internet network or internet, I can say. Okay. I have downloaded, I am sending it over the internet, okay, to a different machine. Okay, I have received this code in my Linux machine. Okay, I have received this code in my Linux machine. I am trying to execute this from my Linux machine by using the C engine, because C engine is independent. C engine is completely dependent for Windows machine, and it is a completely dependent one for Linux machine, and it is a completely dependent for whatever the machine that you are using. But try to execute this code will not work. This code will not work. Why it will not work? because this code is specifically generated for the Windows machine. It means you should execute this code only in the Windows machine, not in any other machines. Able to follow? Here the platform dependency concept is coming for C and C++. So very simple. So you are using the Windows machine, you are writing a C program, step 2, right? Performing compilation. After compilation, okay, executable code has been generated. Okay, this executable code has been generated as per the Windows specification, because you are using Windows machine. That's why Windows related executable code is generated. It's like if you know Tamil, you can talk to the Tamil speaking people. It's not like if you know Tamil, you can talk Tamil to the Telugu speaking people. They won't understand, right? Same thing like that, right? So if you take this code, if you take this, or what we call it as, if you download this executable file and if you try to transfer it over the internet to a different machine, and if you try to perform the execution in the different operating system, that will not work, because this code is specifically generated for the Windows specification, not for the Linux specification. That's why the concept of platform dependency is coming in the C and C programming language. As simple as that. Are you able to follow? Right? So idea is very simple. Text.exe file which contains executable code. However, it is generated as per the Windows machine specification. In future, instead of Windows, if you switch to Linux operating system, okay, instead of Windows, let us say that you are using or Unix operating system. Okay, a code will be generated. This code will be generated as per the Unix specification, Unix understandable format. And if you try to send this text.exe file over the network to a different machine, such as Mac machine. So this is now this is Mac machine. You are sending Unix executable code to a machine called Mac machine, and if you try to perform the execution inside the Mac machine, it will not work, because Unix should be meant for Unix only. No other thing you can do it here. Okay, that's why the executable files that is getting generated by the C or C++ programming language is always what? Is always platform dependent. Always remember. Always platform dependent in nature. Able to follow? Yes, no? Type something in the chat box. Am I audible? What is 10 minus 2? Everyone? 10 minus 2, guys. What is 10 minus 2? Put it in the chat box. Come on, everyone. Yes. Yes, I'm giving the broader picture here. Why C and C++ is platform dependent programming language. This understanding is highly required. Making sense, everyone? Yes, no? Yeah. Okay. Now let us move. Okay. Now now just read this, guys. If any programming language allows its application to perform compilation execution on the same operating system, the programming language is called as platform dependent programming language. Don't you think that we are giving justification to this theory? Yes or no? Are we giving the justification? So compilation and execution, if you perform compilation and execution on the same operating system, that concept is called as what? Platform dependency concept, which is applicable for C and C++ programming language. Okay, the moment you break this rule, it will not work. The moment you break this rule, okay, if you try to send this executable code to a different operating system, it will not work for C and C++ programming language, because it is defeating the purpose of platform dependency concept. Right? Now, second, the $1 billion question. What is the $1 billion question? Why Java is platform independent programming language? We have understood why C and C++ is platform dependent, right? Now we have to understood why Java is platform independent, right? So let us draft the theory first, then we will expand our understanding. Okay, so I'm copying the same thing here. If any programming language allows its application to perform compilation on one operating system and the execution on the other operating system, same or other operating system. I'm taking same or other operating system. Then that programming language is called as what? Platform independent programming language. Independent programming language. Example. Java. Okay. Let us understand this better by using the paint screen. Okay. So now, okay, this space is okay. I want to take I want to take a new machine. Okay, I have a machine, guys. Okay, this is my machine. This time, since I am using the Windows operating system, I am okay to use the Windows operating system every time. So my machine is working on which operating system? Windows operating system. Windows. Now I am explaining why Java is platform independent. Why Java is platform independent. Stay focused at Windows operating system. I have a machine that works on Windows operating system, right? So in my machine, I am writing a piece of Java code. Okay. So let us keep the code simple. My code is going to be the same like the C code, a pseudo code. You do not have to. This is really not a Java code. Just a few set of instructions. Okay. Int a equal to 10, int b equal to 20, int c equal to a plus b. Okay. So what did I just say? Whenever you're writing a code, that part is called as what? The source code. So any language, you can write code in any language. You address it as what? You address it as source code. Since you're writing a Java code, you need to save that with an extension. If it is a C, .c extension. If it is a Java, .java extension. So I want to take the name of the file as test.java. So this .java is representing that the file that you're saving is a Java file. Right? What I just did, I have opened my computer and I have written a piece of code in the notepad and I have saved that with .java extension. So this .java is talking about extension, ext, means this is the Java programming language. And test is talking about what? Name of the file. Name of the file. You can give any name. In future, we are going to understand this thing in detail, but our understanding is limited to the platform independency. Okay, so we are focusing on that. That's why. So source code has been taken. Okay, after writing the source code, you need to perform the compilation. Why compilation is mandatory? Because compiler is going to check if there are any errors in the source code or not. Right? So even the Java will go through the compilation procedure. Okay, compilation. Okay, after compilation, now here the tricky part is after compilation, when it is Java. So what compiler is going to do? So this is the first step, guys. First step, open the computer. Okay, second step, write the code. Okay, third step, perform the compilation. Compiler is going to check for errors. If there are any errors, it is going to throw the errors. You need to correct that. If there is no error, it is going to generate a file. Okay, if there is no error, a file will be generated by the compiler. What file is that? For Java, the name of the file is called as what? The .class file. .class file. The name of the .class file is same as the saved name, which is what? Test.java means. It is going to be what? Test.class file. Okay, so this file is going to have a representation. You don't even understand what is inside. It will be in the form of symbols. You really don't understand. It is not like zeros and ones. Okay, everything will be in the form of what? Symbols, zeros and ones, symbols. Okay. So this code is called as, you call this code as byte code or intermediate code or .class file. Okay, so this byte code or this intermediate code or .class file is neither understandable by the programmer nor understandable by the computer. Computer will not understand this. Computer will not understand, as well as the programmer will not understand. That's why it is called as what? It is a kind of intermediate code. Okay, so what has happened so far? There are 4 steps involved. The first step is you open your machine, which is Windows operating system. You have written a piece of Java code, right? And you call it as what? Source code. Okay, this part is this is done. You call it as what? Source code. After this, you perform the compilation. If there are no errors, the compilation is going to generate a file. The name of the file is called as what? Dot class file. You call the code, okay? So this will be in the form of symbols. Okay? You call this as what? The byte code, you call it, or you can call it as intermediate code, or you can call it as what? The dot class file. Okay? Dot class file has been generated. This is intermediate. This is intermediate because it is neither understandable by the programmer. You cannot understand this, and even the machine cannot understand. That's why we call it as what? The intermediate code. Okay, so far so good. So far so good. Now you need to pay some attention, especially the fourth point. Especially this fourth point, very, very important. Okay, some attention is required. The fourth step. Okay. What does it says? Dot class file contains byte code or intermediate code, or what you can call it, whatever it is. Okay? It is not directly executable code. So when I say it is not directly executable code, you cannot generate the output. You cannot even execute this to generate an output. Okay, this is just a kind of an intermediate code. You cannot even use this to generate the output. There is another step that should be followed after this particular code generation. Okay, it is not directly executable code, but earlier in the C programming language, so this is the directly executable code, right? This is the directly executable code in the C programming language. This part, directly executable code. But when it comes to Java, it is not directly executable code. It's an intermediate code. Okay. We can call it as what? A minute, guys. Let me change the color. Okay. It is an intermediate code. It is not representing any OS representation. It's not representing any operating system representation. You might be wondering, we are using Windows machine so that it is representing Windows machine representation. No, it is not like that. It's not representing any operating system representation. Right? So far what happened? 4 steps are involved. First step, second step, third step, and fourth step. A bytecode has been generated, but this bytecode is what the explanation for the bytecode. What the bytecode says, it is not a directly executable code. You cannot execute this. It is an intermediate code. It is not representing any operating system. Okay, whatever the machine you use, even though if you use Windows operating system or Mac operating system or whatever it is, the code is going to be common for all the operating systems. The code is going to be what? Common for all the operating systems. Then what after this? What are the steps involved? That should be the question, right? After this, what is happening here is, okay, let me take a layer here. Okay. After this, there is a stage called the execution stage. Okay, let me keep that execution stage somewhere around execution. Okay. After the execution stage, you get the output. Let me keep the output as like output is going to be what? 30. But anything, output can be anything. Instead of 30, let me keep it as output. OP means output. Okay, this is the execution phase. This is another execution phase. Let me divide this into 3 separate parts. This is another execution. Focus here. So fourth point says a bytecode has been generated after the compilation. Okay. After this, there is a stage involved here. What is the stage is? So after generating the bytecode, so this is the bytecode, right? So this is the bytecode. This is the bytecode. Okay. This bytecode is not representing any operating system. It is not. It is independent of operating system. It is not. This is the bytecode, and it is not representing any operating system. What does it mean? In future, you can download this bytecode, or you can download this bytecode or dot class file. You can call this as what? Test.class file. Let us say that test.class file. You can download this to your system, and you can attach this in your email. You can attach this you can attach this to your email. Let me attach this to the email. Okay, and after attaching this to your email, you can send it to your friends who are using the Mac operating system. You are using the what we call it as Unix operating system, and you are using the Solaris operating system. Okay, you can send it to your friends bytecode who are using different operating system. Okay, so the moment it gets picked up by Mac operating system, this Mac operating system will ensure that this bytecode is getting converted to the executable code according to the MacBook. Or the moment it is picked by the Unix operating system, this Unix operating system will ensure that this dot class file is picked up by Unix operating system, and it is going to get converted according to the Unix operating system. Or if it is picked by Solaris, by the person who is using the Solaris operating system, so the dot class file will be converted according to the Solaris's operating system specifications. Okay, so there is a converter involved between. There is a kind of what? The converter involved in between. Converter. So let us go back to this code. So in between this execution, there is a concept called, there is a program called converter is a program. One converter is involved in between this execution and the bytecode. Here one converter, and here another converter, and here another converter, right? So we join these converters. Okay, so after generating the bytecode, okay, you can, the combination of this converter and the execution, the combination of this converter and execution is called as what? Together we call it as what? The JVM. JVM stands for Java Virtual Machine. Likewise, the combination of converter and execution, combination of converter and the process of execution is called as what? The JVM. Inside the JVM, you have converter and the process of execution. The combination of converter and the process of execution is called as what? JVM. Okay. So these three JVMs are representing different operating system. Let us assume that the first JVM is representing what? The Unix operating system. The second JVM is representing what? The MacBook operating system. The third JVM is representing what? The Linux operating system. So what is the observation so far? Okay, first one is you have written a code in Windows operating system, right? And you perform the compilation. Compiler has generated the dot class file or intermediate code. It is neither understandable by the use programmer nor understandable by the machine. Okay. After this, you are sending this dot class file to three different operating systems. Focus here. One is Unix, second one is Mac, and third one is Linux operating system. Okay. The moment it is sent to Unix operating system, from here, we're sending it to Unix operating system. What is actually happening? Okay, this dot class file will be converted according to the Unix operating system representation, or this dot class file is going to convert the code into the executable code that is understandable by Unix operating system representation. Or else, if you are sending this dot class file to the MacBook operating system, okay, this dot class file will be converted to will generate the executable code according to the Mac operating system representation, or according to the representation that is understandable by Mac operating system. Or if you are sending this dot class file to the Linux operating system, this dot class file will be converted to executable code that is understandable by the Linux operating system representation, which is actually doing this conversions, actually these converters. Okay, so each and every operating system will have their own converter, so that converter will convert the bytecode to its exact operating system representation. In this case Unix, in this case MacBook, in this case Linux. Right, so in this case, if you observe this bytecode is common. You can add this bytecode to any number of operating system. You can write the program only once, guys. You have written program only once. What did you do? Just to you return the code only once. So write once. Right, after writing once, you have generated the bytecode. You can send this bytecode to any number of operating system. It means run anywhere. What did I just say? Write once and run anywhere. Write once, WORA. WORA is an acronym, standard acronym for what? WORA. WORA means what? Java. Write once and run anywhere. Run anywhere. When I say this, you are writing the piece of code only once. You are writing the code only once, and you are generating the dot class file. You can send this dot class file to any number of operating system, no matter what. That will get executed according to the operating system. Why it will get executed? Because each and every operating system will have a JVM. A JVM is a combination of converter and the execution process. Each and every machine has its own JVM. If you are using the Unix operating system, okay, this Unix operating system will accept the bytecode in such a way that bytecode is going to get converted to the executable code according to the Unix representation. Or if you are using Mac operating system, it will accept the common bytecode in such a way that common bytecode will be converted into the executable code according to the Mac operating system. Okay, here the bytecode is common. Okay, depending upon the operating system that you choose, that bytecode is going to convert it to the executable code, and the relevant output is going to get generated. Don't you think that there is an independency nature here? Don't you feel that there is a platform independency? You are writing your code in Windows only once you are writing this code in the Windows OS operating system, but you are able to execute it everywhere with the concept called WORA. WORA means what? Write once and run anywhere, which is actually performing the platform independency, which is actually making us to enable the platform independency. This bytecode concept. Bytecode is a common code. It is neither understandable by the humans nor understood by the machine. But you can use this bytecode to send it to different operating system. Okay, if it is sent to Unix operating system, inside the Unix operating system there is a concept called JVM. This JVM will convert the bytecode to its respective machine and understandable code, or to the respective executable code as per the Unix specification. If it is Mac, as per the Mac specification. If it is Linux, as per the Linux specification. Okay, now if you talk here, if you observe one thing, Java language is platform independent because of the bytecode concept. But JVM is platform dependent. We will understand JVM a little bit later, but today the topic is platform independency. Okay, I am just giving you a small picture about JVM. JVM is platform dependent because it is dependent for it is unique for Unix, unique for MacBook, unique for Linux operating system, unique for Windows operating system. But JVM is what? Platform dependent in nature. Okay, what is the observation that we have made here? Okay, whenever you're writing a piece of Java code, it's simple. If you're writing a piece of Java code, okay, it has to go through what? Compilation. After compilation, dot class file will be generated. Okay, this dot class file is an intermediate code. You can send this dot class file to many operating systems if you want. Okay, if you have MacBook, okay, you can send it to Mac operating system, or you can send it to Linux operating system. Okay, Linux operating system, or still you can send it to Windows only, Windows operating system. So each and every operating system will have its own JVMs inside. Okay, so this dot class file will be converted to the respective machine specification by the JVM. This dot class file will be converted to the respective machine specification by the JVM. This dot class file will be converted to the respective machine understandable specification by the JVM. So that executable code will be generated. Okay, MacBook will generate an executable code, and Linux will generate an executable code, and Windows will generate something an executable code. Okay, all these executable codes are generated according to its JVM, according to the installed machine. But the dot class file is common to every machine. That's why it is called as what the platform independent in nature. Okay, you can write code once, you can compile it, and you can send these dot class files to any systems. It will work. Why it will work? Because each and every machine has its own JVM that will take care of the execution. That will take care of the conversion and the execution. Okay, that's why we call it as what? That's why we call it as specifically what? The ORA. ORA is what? Write once and run anywhere. Okay, if you remember this word ORA, it is enough. What is ORA? ORA is what? Write once and run anywhere. You can write program only once. You can run any number of times. Able to follow? Yes, no? What is 1 minus 1? Everyone? What is 1 minus 1? Hello? What is 1 minus 1? Yes, sir. 0, sir. Good. Yeah. Okay. So this is what the concept of the platform independency. So let us do a quick recap. Why Java is platform independent? Why C and C++ are platform dependent programming language? In C, you have only executable code. Directly the executable code will be generated. Point to remember, in C directly the executable code will be generated, whereas in Java executable code will not get generated directly. Instead of that, dot class file code will be generated. Dot class file code will be generated. After this, it's up to us to send it to different machines to perform the actual execution depending upon the operating system. Able to follow? Right, now go by theory. Now if you see, if any programming language allows its application to perform compilation on one operating system and execution on the same or another operating system, then that programming language is called as what? Platform independent programming language. Hope this is making sense now, right? This is making sense now, right? So this is the third popular interview question. Okay, if you answer this is fine. If you can answer this is going to be fine. If you want to elaborate further, you can just explain. You can write down this diagram, or you can imagine things from this diagram and you can explain it to the interviewer. I will give you the complete notes and I will send it to your email addresses. So every weekend I will send the notes. If you have time, you can write it down when you are watching this video, or if you have time, you can write it down. So that's all from my side for the today.